Okay, looks like we're live. This is lecture 28. It's the last lecture. Let me fire this thing up real quick. This is the last lecture for CS 2690. It's going to be fairly short. It should be about a half an hour or less. I want to begin with, let me just make sure that I've got, that's looking right. Yeah. At the end of 27, there was this video, and I want to just play it. I mean, you can go hit this link right here, but I want to play it, and I'm hoping that the audio comes through, and if it doesn't, please forgive. And that is not swapping. Okay, so let me go, just a second. Yeah, let's just do that. I'll do it from here. Okay, that's really choppy. I don't know if you can hear that audio, but it's really, really choppy in terms of what I'm hearing. Anyway, that's the link right there. And so go watch it. It's really just a decent summary. So I'm just going to leave it at that. And then what I want to do is, let me bring that back. It just kind of recaps the idea of certificates and authorities, and kind of ties it in with SSL and TLS just a little bit. So here's what's important to know. This secure transport layer is between HTTP and TCP. And if you think about it logically, it has to have a secure, guaranteed sequenced packet delivery mechanism to deliver. That's TCP, and it's used for HTTP. So it's a secure layer that's inserted between those layers. Okay, and then these are some of the features. Excuse me. All right, these are some of the features, and just go through this list. Data is encrypted. It can't be tampered with, right? Remember we talked about keeping it private is one thing, making sure it can't be tampered with is another thing. Mutual authentication of who the other parties are, and errors are handled securely, and the browser and the server get to negotiate the specific set of features that they're going to utilize. And I believe, yeah, that's it for 27. Not that big of a deal, but we just hadn't finished 27. So I want to jump over now to 28. We're not going to go through all the slides in 28. Again, making sure that we're here. Literally, we're only going to hit like 6 or 7. Oh, and I did want to double check on 27 whether there was any like test questions. No, that related to those last couple slides. Any test questions I wanted to share? The answer is no. Okay, 28 TLS. Here's where we're going with this thing. This is just kind of a history of SSL and TLS. And what you find is one of the interesting things is this thing starts in 94. That was actually 94, 93 or 94 was the first year that I saw, it might have been 94, but that I actually saw a web browser, and it was Mosaic. And so one of the things that you realize is that when you create a new thing, technology is created first, and then risks and dangers and issues show up kind of after. you don't anticipate them or see them up front. So you create these technologies and you're not thinking about security because the bad players haven't shown up yet. I mean, the bad players were always there, but hibiscus tea, so delicious. But it's not until it shows up, and then all of a sudden, of course, the bad actors show up, and you begin to have to, deal with stuff. So it's not till '94 where you get version 1 of SSL. And it's about certificate exchange and the establishment of a secure browser session. Okay. And so it was designed for Netscape, then released. Then you have SSL version 3. Then with SSL version 3.1, they renamed it to TLS. So when you say SSL or TLS, you're really talking about the same thing, except for the fact that TLS is version 3.1, kind of a reset. And SSL version 3 was the first real de facto standard. And what else to say? Then we go updates, et cetera, where now we get message digest stuff with the SHA stuff and, support for, and, enabled in Firefox and Chrome. That's really all I want to say about that. Just understand that as soon as this kind of technology showed up, then we got sort of the arms race shows up at that point. And then it's been basically a race ever since. This right here just reinforces what we were saying earlier on the previous slide from 27, that TLS lives between HTTP and TCP. It also lives between SMTP for email and VPN for virtual private network. But relative to HTTP, you can talk HTTP straight on TCP, or when you say HTTPS, it means that you're running over TLS, okay, using TCP port 443 as opposed to port 80, which is normal web port. Okay, that's all. If you're running HTTP over just directly on TCP, it's going to say HTTP:// and it's therefore not secure. And if you're running HTTPS, it means you're going through TLS. That's it. There is a test question that gives you pictures of protocol stacks and asks you which one is the correct one. The correct one has HTTP and then TLS and then TCP and then lower level protocols. That is the correct one. You can picture this in your head. Dave recommends this book. I don't have this book, so I can't speak directly to the book, but I'll trust the value of it. Okay. And here we go. I'll tell you what I want to say about this. And by the way, there's a few questions, and I'm going to change some of these questions. The questions are basically classic questions like we've had, memorization of these steps that makes, it just turns your brain to mush. So don't worry too much about that. But I do want to say this. This is what's critical, and I'm going to look on my big screen because there's a lot of text. You can kind of look through this. One thing that's easy to see is time flows down, client on the left, server on the right, and you can see that the client sends a handshake, the client hello to the server. This is all done in ways that are facilitating security. It includes some things like the generation of a random number and but importantly, a list of encryption algorithms. Like the client basically says, here's all the encryption algorithms I can speak. Then the server responds back with a server hello. That's the response. And it basically selects, so the client says, here's the 5 encryption ciphers that I can use. And the server just simply picks one. It doesn't have to tell all of its capabilities. It just picks one. It then sends, and it provides a session ID and does some things again that are kind of low level key generation stuff, confirms the TLS version. And then it says, whereas that's number 2. Then number 3, it sends a certificate with the public key. So now the client has the public key, and you should by now, even though it's been a lot of stupid Trivial Pursuit crap, by now you should have a sort of a sense that we can exchange. I need to know who you are before I establish a symmetric key session relationship with you. So the server says, this is who I am. I am, in fact, Amazon, or I am whatever, the server you're trying to talk to. And then it says, I'm out, done, which is number 4 right here, server hello, done. So I now have the certificate, so I can now send you my symmetric key. Sends a client, number 5 here, if you notice, sends a client key exchange message that contains a randomly generated number called the master secret, encrypted with the public key, and that's used by the server to generate its master key, which is called the master secret, which is used to generate the shared symmetric key, et cetera, et cetera. Okay? And then I send another message called change cipher spec, and it indicates that all subsequent messages will be encrypted using the data encryption cipher that was negotiated earlier. I then send a finished, and then it allows me to confirm that the entire prior exchange had been done securely, and then we're done. At that point, I can swap data, do my data thing, which doesn't have a number, but you get the idea. And then we can close. Okay. So it's a butt ugly slide, but it's not crazy bad when you get down to it. And this is the TLS handshake. Having done that, we now have HTTPS up in the browser thing. This is what the data stream looks like. There's the data stream coming from the app. Let me see, where is it in my notes? Oh yeah, the MAC is the process of encrypting the message digest. So you got this data fragment and this encrypted message digest. Then you've got the data encrypted plus the MAC. Now my understanding, and I may have this wrong, and it doesn't matter in terms of what you're accountable for, but that the MAC is already an encrypted digest. And then you take the data fragment, you encrypt it, and then you tack on the MAC, which is already an encrypted digest of the original data. So you can pull both parts off, decrypt the digest and decrypt the data, and then apply the digest to the data to make sure that nothing's been tampered with. There are a handful. Then this one, if you notice up here, it shows like record header and then the encrypted data. This just shows right here the type, TLS version, record length. Again, that's kind of the record header right here. There's the encrypted data, and then there's the SHA. That's the encrypted message digest, and then there's a pad to make sure that you got the right length of 8 bytes. That's 8 bytes times whatever the length is. Now, here's the deal, because we're basically done. Everything else from here is stuff we're not going into, and I want to just share. So literally, it goes an SSL dump trace of client. This is just kind of trying to walk you through in the grungy detail what's going on, but I don't really care. It's a level of detail that I don't think we need. It's grungy. NSA suite of cryptographic algorithms effective '05. I don't care that much. I really don't. And then there's a quiz. So just be aware of the quiz, lectures 24 to 28. The previous quiz, I believe, went 20 to 23. That, ready? End of chapter 8 slides and end of course. That was like 12 minutes. There's one question. Again, I hate all the questions. Which organization is not involved in cryptographic technology research or standards? Okay, let's go with the ones that are. RSA Corporation. You should remember that one. NSA. Got to remember that one. NIST, which is National Institute for Standards and Technology. NIST. Got to remember that one. Should remember that one probably. And then finally, the FCC, the Federal Communications Commission, not involved. I finished my hibiscus tea. Seriously, I recommend it. That is another question. I may alter that one to make it even more obvious. And then there's a few others that I'm not going to share yet because they're just too obscure. We will. I'm going to try to get together with everybody. Maybe we can do a Discord session or a team session, or get together in person on one of these Mondays or Wednesdays on campus, and do a little bit of prep for the exam for the final. Um, I'm sure you guys would appreciate that. I know I didn't cut you a lot of slack on the test stuff, partially because I was just so slammed. But I think that I might be in a position to, when I've got the final a little bit more cooked, uh, to be able to go um, and have a little final prep help section, maybe on the last day of the semester for us, which would be the 8th on a Wednesday or Monday, either way. All right, my friends, that's all I got for now. We are done, and hit me up on Discord, and actually, please don't email me on Canvas. That interface is just so bad. And if you want an interactive, back and forth, the easiest way is Discord. So I beg you, and if you can't do that, then shoot me a regular email at my UVU email address. That's all I got. I will talk to you